And you've seen this problem on ACCs, on Algebra 2, math analysis, and now we're going to do it in calculus. So basically, it's kind of like you have this material of whatever sort it is, whether it's metal or paper or whatnot. And right now, they're saying it's tin, okay? And you're going to try to maximize the volume you can get by using this to create a box that has an open top, okay? So basically it's telling you the constraints are that when you take these sides out, they're going to be congruent squares. So if this is a 20 by 25, what's the farthest in X could go? Basically, if I'm going to be folding that up to make a box. So if this whole length is 20, and I'm taking an X and I'm taking X, right? Okay, so what's the max I could have to take it into for X is 10? But it can't be 10, or it would just be flat, right? Well, we have to have a little bit. So if I'm going to talk about my domain here, what would be the domain for the X along that 20 side? Less than 10, but greater than 0. Okay, what about on this side? The 25 in this case side. Less than what? 12.5, but still greater than 0. So if I'm talking about X overall, am I going to look at this constraint for the domain or this constraint for the domain, the smaller? Okay? So in this case, I know my domain is going to be between 10 but greater than 0. Yes? Okay. So then it says that I take these squares out. Oh. All right, real quick. So I'm taking these squares out. And I'm not quite sure. I just kind of guessed how far I wanted to go. Okay? So if I took out some unknown, and this started with 20, so I had this guy going on, started with 20, but I took out some unknown, what's left right here? Good. 20 minus the 2x. And similarly here, if this whole thing was 25, but I took out all these x's, what would be left here? 25 minus 2x. Why? Who can answer? Yeah, x and x is the same. You're taking out squares. So you're taking out the same length. Okay. So then I'm going to fold them up and make my little open box. So it looks something like this now. Okay. I don't know. Of course. Okay, so I made this open box going on. And it wants me to maximize what equation? Volume. So let's write our volume equation. So volume is going to be what? Perfect. Length times width times height. But what can we put in? What's the length of that box? What's the width of that box? And what's the height of that box? 25 minus 2x, 20 minus 2x, and x. Is that okay? I'm trying to find the maximum or minimum, what do I want to do to this equation? Not graph it. Well, we're using calculus. So we're going to derive it. Do you want to do a product rule with three things? No. Neither do I. So what would be a smart move? Okay, distribute it all together. Get your equation. Go. All right, so that's what I got when I distributed everything. Everybody good? Now I will derive it. And here, I need to find my critical number, so I can set this guy equal to 0. There's no undefined places. So when I set it equal to 0, what could I factor out to make life a little bit easier? A 4 looks like the biggest thing. What's 180 divided by 4? 45. And 500 divided by 4? 125. And I'll give you a hint, that's not factorable. So how else could we solve this? Quadratic formula. You can also complete the square, for those of you who said no.
That sounds terrible.
All right.
I think it works.
So go ahead, solve. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Well, I'm not worrying about that 4. Oh, sure, yeah.
Numbers like this.
So right now for today, you guys can use your calculators, okay? So for time purposes. Are you guys getting that on your own, right? All right, go. Get your calculator out. So after you get that, tell me what they are approximately, because I can't check that in my domain. I need to see what it would be approximately. Okay, so I heard 11.3188, and what else? 3 point what? 6812. Okay, when you guys have these rounded answers, I can see that it's going to ask me to find the volume. My final answer for AP has to be correct to 3 decimals. So if I round here too early and then go put it into an equation, could I possibly be off within 3 decimals?
Yes.
Yes. So my little advice for you is to go out about 6 decimals before it's the final answer. So final answer accuracy has to be 3 decimals. And I would be sad if you missed it because you rounded too early. Okay? So I'd go out about 6 decimals from what I'm going to plug in. Now, before I keep going, what can I definitely say? Think about your domain. Okay, the 11 point whatever is out. Okay? You would subtract more paper than what you, or 10 in this case, than you have. Right? Because 1 length is 20. So, okay. Now what do you have to check for that 3.6812? You're looking that it's a what? A maximum. If you don't check right here, you do not check, all the points after that are void. You will not get any more points. You have to show me that this is a relative max. Okay? I don't care if you do the first derivative test or the second derivative test. So I don't care what you do. Go determine if that is a relative max. You're either using the first derivative test or the second derivative test. Okay, so did everybody get relative max by one of these 2 tests? Anybody want more time? Give me a little hand raise or something. So if I'm using the first derivative test, I would say it is a relative max because why? If I asked you for a justification, why is this a relative max? Because why? What's your justification? So that's it.
I'm talking to myself.
Okay.
Because remember to the second.
Well, we're going to talk about that over there. If you use the first derivative test, I'll come back to you for the second derivative. So close. Don't say it, because what goes from positive to negative? Because well, we didn't use F, we used V. Okay, so because V prime. Okay, so never use it in your explanations. You're going to get it wrong. I don't know what it means. So because V prime went from positive to negative at x equals approximately 3.1 or 3.6812. Okay, so that would be your justification there. If you did the second derivative test, then what would you give me for your justification?
The second derivative is negative.
Okay, therefore, yeah, so this n b prime of this guy equals 0, right? With those 2 things, I know that I have a relative max. Okay, Is that okay? Now answer the question in what? answer your question now. So there's actually two questions. How large should the squares be to make the box hold as much as possible? So that part would be the 3.681, what are we in? Inches by 3.681 inches. Is that okay? And then it says, what is the resulting maximum volume? And this is where we have to be careful of the rounding. So when you put that in for the excess, make sure you put it in about 5 or 6 decimal points. The store feature on the 84 would be perfect for this one, so you don't have to type it over and over and over. You guys want me to show you what I mean by that? Okay. Oh, I think I already have it. Okay. So when I'm here, if I did 3.6812, give me 2 more decimals.
I got 1186.
Okay, 1186. Thank you. I'm going to store, so I'm going to use that little store button in for X. Then I'm going to go type in what my equation was. So it was 4x cubed minus 90x squared plus 500x. And when I hit enter, it's used that guy into the x's, so you don't have to write it over and over and over and over. Okay? Don't do that in your 89s. Don't do that in your 89s. It does something else. You don't do that in the 84. I like to have both calculators. Something the 84 is 89. So the answer to this guy would be, what was it? 820.3 decimals. 528. And how do we label that? Inches cubed. Okay. So for a summary on all of these, I want you to tell me top mistakes students make. Okay? Tell me what you think are the top mistakes when doing this. Rounding too early. Good. What else? Huh? Okay, labels. Good. That's 2 of the 4 I really want you to know. Okay, so in context with the labels. Good. Yes. Perfect. So justify the relative min or max. Very good. Probably the biggest one. Can you think of any more? Do the process. Tell me what you mean by that. Any more you can think of? Okay, get the right equation to optimize. Okay, in terms of how many variables? Okay, in terms of one variable. Okay, so point to your group leader. All right, so who you guys point to? Ryan, who you guys point to? Cogley, who do you guys point to? Rose? Chris? Ryan, okay. Group leaders, pick somebody to summarize the steps in optimization.